Today we're going to talk about Newton's first law of motion, and in this video there's going to be four things we're going to talk about. We'll talk about force, we'll talk about friction, we'll talk about Newton's first law of motion, and then we'll talk about the actual word called inertia. We'll talk about what that means. This video is intended to be short, and then after the video you'll have a quiz that you'll have to take and get an 80% on in order to do the work for the next day. So let's start by talking about force. What is force? Simply put, it's a push or a pull. So this little cartoon character here is pushing the box. He's adding force to the box. So if he's pushing on the box in this direction, which way do you think the box will end up moving if he applies enough force? Well, it's going to go to the right. That's force. And we can actually put numbers to force. We can calculate how much force is being applied to an object. Since Newton was the guy that discovered this or came up with this idea, we call force in terms of the word Newton or N. It's just like mass. If we calculate mass in grams, or time we calculate in seconds, or volume we calculate in liters. Well, when we talk about force, we call it a Newton, and so that's just represented by an N. So an N is called a Newton, the measuring unit for force. So if this guy is pushing in this direction, and this guy over here is pushing in the opposite direction, if the one is pushing with 2 newtons, or 2 amounts of force, and the guy pushing in the other direction is also pushing with 2 newtons, then overall, the force applied to the box is 0 newtons. It doesn't move. We call that a balanced force because the same amount is being pushed and applied on both sides. But if the guy over here pushes with 2 newtons of force and the guy on the other side pushes with 4 newtons of force, then which one's going to win out and by how much? Well, we know it's going to be 2 newtons and it's going to go to the left. This guy wins out because he's pushing with more force. And how much force is he going to have that's pushing against the other guy? Then he'll have 2 newtons more. Same thing applies. If this guy's pushing with 2 newtons of force and the guy on the other side is only pushing with 1 newton of force, then the guy on the left wins out and he pushes it by how many? By 1 newton. And which direction? Of course, to the right. So that's called a net force. And we can calculate how much of force overall is being applied to the object. Same thing goes if they're both on the same side. I don't know if you've ever had to move a large object like a refrigerator or a couch or something, but sometimes it takes more than just one person to move something. So if you both stand on the same side and both of you are applying 2 newtons of force, then how much is actually being applied to the box? Well, of course, 4 newtons. And which direction will it move? It's going to move to the right, or the direction that they're both pushing. Well, what actually resists then force? If you're pushing and force is moving one direction, what's a form of resistance? Well, we have what's called friction, and friction is the force that opposes the sliding motion of 2 surfaces that are touching each other. So you see in this diagram, here's the floor, here's the box, and it's being pushed to the right, but there's this friction force, the force of the 2 objects rubbing together, that actually resists that force and pushes the opposite direction. 2 things affect friction. One is the kind of surfaces that they are. So depending on how smooth or how rough one object is compared to the other one, if you're moving, I don't know, a couch along a rug, it might take more force to overcome that friction than it would be to have like a sled on snow. That's going to be a lot less friction and a lot less force required to get you to move. And then the other thing that is required, or that affects friction, is the amount of force that's pressing the surfaces together. So if somebody gets on the couch that you're trying to move and is pushing a downward force on the couch, then that is also pushing a downward force onto the carpet, requiring you to push even harder to get the box to move and fight against the friction. That's friction. Then we get to Newton's first law of physics. So this is his first one. There's a total of 3. I'm sure you've heard this law before. It simply states that an object in motion will stay in motion unless acted on by another force. And so when you look at this baseball player, once he's swung the bat and hit the ball, then the ball, according to Newton's first law, should continue in that direction forever. It should go right on into space and project itself right through the universe in that same direction at the same speed, never speed up, never slow down, never move. But we know on Earth that doesn't exactly work that way because there are other forces at play. We have some other forces. What we tend to see, what should be seen according to Newton's first law, is that ball should just go on in the same direction forever and ever. But what we actually end up seeing is something more along the lines of this arch, where the ball goes up, and then other forces, like you might be thinking already, gravity. Gravity is pulling down on it, so that will change the direction. It will also change the speed of the ball. And there's another force that is less common, we don't think of so much, but it's also friction. Friction in the air. That's called air resistance. And the friction of the ball rubbing up against the molecules in the air also cause it to slow down. And then gravity will pull it down. So 2 obvious, powerful forces affecting the ball that contradicts, or not contradicts, but goes against his first law of physics, where the object should continue in the same direction forever and ever, except here are 2 opposing forces that are acting on it, changing the direction and the speed of the ball. That's Newton's first law. Along with Newton's first law is the idea of what we call inertia. And this is an important term. The word inertia is the tendency of an object to resist any change in its motion. Going back to that baseball player, that ball has inertia. When it was hit, it should never have stopped. It has inertia. It doesn't want to stop. It would continue going in that direction forever and ever and ever, except other forces act on it. But the other forces that act on it have to be pretty strong. They have to be stronger than that ball's inertia, that tendency to resist change. So once gravity and air friction actually are greater than the inertia of the baseball, it will change the speed and direction of the ball. Otherwise, the inertia would keep it straight. In fact, the same thing goes for something in standing still. Everything, even if it's not moving, has inertia. It requires force to actually move something that's standing still. Let me give you an example. One thing that affects greatly the inertia of an object is the mass. The greater the mass, the greater its inertia. For example, if you're looking at this bowling ball versus this tennis ball, which one do you think has more inertia? Well, even if they're just sitting still, it would take more force to move this bowling ball that has a very large mass. It takes a lot of force to get that ball to move and fight the inertia. And this small tennis ball, it would take much less force to get that to move to fight against its inertia. So the bowling ball has more inertia. But once you do get it to move, once you overcome it with enough force to get it to move, then according to the first law of motion, it should continue in motion until it's acted on by another force. It's much more difficult to stop a bowling ball because it's such a large mass that as it moves, its inertia is large and it doesn't want to change. So it takes much more effort, much more force to stop a bowling ball that's moving than it would to stop a tennis ball that's moving, because of the mass of the tennis ball. It's so much less than the bowling ball. That's the idea of inertia. So in review, we know that a force is a push or a pull, and that the net force is the total force of an object, of all the forces being applied to it. So if something is pushing this direction with 4 newtons of force, and something's pushing in the opposite direction with only 2 newtons of force, well, the object, with the first thing pushing, overcomes by the amount of 2 newtons, and it will go to the right in this case. In real life, there's much more than just 2 people pushing on an object. You would also have gravity that you're fighting and friction that you're fighting, and you would have to calculate all of those things to find the net force of an object. Friction is the resistance of 2 touching surfaces, including air resistance. That's also a form of friction. The first law of motion says that an object in motion will stay in motion unless it's acted on by another force. And inertia, which is a part of the first law of motion, is the tendency of an object to resist any change in motion. Once it starts moving, it doesn't want to stop. If it stopped moving, it doesn't want to start. It wants to resist, and it requires, depending on how large it is, the mass that it has requires more force in order to overcome its inertia. Alright, you can stop this video, you can replay it, you can go back and review any portion of it, but then you also have a quiz to take, and you need to get at least an 80% in order to start the work for the next day on the Rube Goldberg experiments.